must be a better way. You're darn right there must be a better way. Listen, if you're a library writer, maybe you would deal with this. But in your regular everyday life, just writing a person class, there is such a nicer way to do it. You see, C++, especially C++11, has what are known as smart pointers. Smart pointers are objects that you allocate in local storage on the stack, as a member variable, whatever. They're solid objects. They're not pointers, despite their names. They have a pointer inside them. When the smart pointer goes out of scope, you know what his destructor does? He calls delete for you. It's such a simple thing. It's actually templated. It'll work with any kind of pointers. A T pointer. So you can give it an integer pointer or a person pointer or resource pointer, employee pointer, whatever. And when you construct it, it keeps a copy of that pointer. When it goes out of scope, the destructor does delete on that pointer. No memory leak. And it can't happen twice. It can't happen too few times, too many times. You're safe. And what about the copying and the assigning? Well, there are different kinds of smart pointers. Some of them prevent copying. So you simply can't copy a unique pointer. Others keep track of how many people are using the pointer with a reference count. Not adding a reference count to person or employee, but inside the smart pointer there's a reference count. And so the destructor just decrements the reference count, and when it gets to 0, deletes it. The constructor obviously increments the reference count, and so does the copy constructor, and so does the assignment operator. And most important of all, operator overloads for a pair of operators you probably didn't think of were operators, even though I say operator every time I talk about them, star and points to. The effect of doing this is that you can treat that smart pointer exactly like a pointer, except you don't have to remember to delete it. It's not garbage collection. It's deterministic destruction. It will get deleted exactly when it goes out of scope or when the last person using the shared pointer goes out of scope. But it feels like garbage collection because you're not writing all that code. And it saves you from having the destructor, the copy constructor, and the assignment operator, the big three, in your class that have a pointer in it. Oh, they're in the smart pointer, but you don't have to write the smart pointer. They come with C++11. You just get to use them. Watch what happens to our code when we do that. I love ripping out code. I think every developer loves ripping out code. Less code to test, less code to worry about. I'm going to go into person and change this resource pointer to a shared pointer to a resource. Now, that's not going to compile as is, obviously. I've got to put an include in here of memory, and I need to call it by its full name, standard shared pointer. Let's talk for a minute about why I chose shared pointer. It implements a reference counted sharing so that when you copy or assign a person around, the new person is pointing to the same resource as the old person. I don't know, let's say it was the car, and you change some aspect of the car. Everybody, all the person objects that were copied from each other, they would all now still be pointing to the same changed resource. The old semantics that we implemented by hand were that each person had their own individual copy of the resource. I don't think there was necessarily a business reason for it. It was just, how else were you going to do it? We weren't about to implement reference counting inside person. In many cases, a reference counted shared pointer is a really good way to deal with copying. If people are making copies of a policy or an employee record or whatever, it should still be referring to the same other things that it needs to refer to. And as long as one of those copies is still in scope, we shouldn't be deleting the stuff out on the free store. So I'm going to use a shared pointer to resource here inside person. Here's the fun part. I don't need the copy constructor anymore. A copy that copies the shared pointer to resource in one person into the shared pointer to resource and another is just fine. The reference count will get incremented. The sharing will happen. I do not need to write this code. So I can get rid of my copy constructor. Similarly, I can get rid of my operator equals. When the assignment happens and it just lands on the old P resource, that's fine. It will do the right thing, send things out of scope if they need to go out of scope. So I can get rid of my operator equals. Here, where I'm initializing it to null pointer, remember how strings just initialize themselves to quote, quote, you don't need to remember to do it? Shared pointers initialize themselves to empty. So I don't need to initialize p-resource, another thing not to worry about. And I sure as heck don't need to delete it in the destructor. When person's destructor goes off, all of its member variables will be cleaned away. The strings, arbitrary number, all of them, including the shared pointer. And the shared pointers destructor will go off, and the shared pointers destructor, assuming that this is the last person who cares about this particular resource, will delete the memory out on the free store. So I don't even need to have a destructor. I told you, love ripping out code. Now in add resource, I do need to worry about the old one. If there was one already, I need to tell it, the shared pointer, to let go of that resource. And I do that instead of using delete like this. The error message, by the way, is you can't delete that. It's not a pointer. It's true. Despite the fact his name starts with P, it's a solid object whose type is what we call a smart pointer. And it has a member function called reset. Resetting a shared pointer has it let go of its hold on something out on the free store. It decrements the reference count, and if that takes the reference count to 0, it will delete it. All done behind the scenes for you, not your problem. Now, you can't initialize a shared pointer by just passing it something that you got from new like this with the equal sign. The best way to get a value into this shared pointer is to use the make shared. It's again a C++11. All of this is C++11. Visual C++ 2010 supports the C++11 language changes. So here, I'm going to use the make shared function. It's a templated function, and I need to tell it, I need you to make me a resource. And then I just pass along the arguments to be given to the constructor. And make shared will take those arguments, give them to constructor for resource, get itself a pointer, put it in a member variable, do all the right things, and this smart pointer will be smart. So I've made person a lot simpler. I ripped out all that code that just took me so long to put in, and that was knowing what I'm doing. But what is going to happen when I run this diabolical main that's running around copying things and calling add resource twice and so on? Let's find out. It's all good. I have 2 constructs, 2 destructs, and I'm not making endless copies of the same resource for each individual copy of the person. There's a lot of persons being constructed that you're not seeing, and they're all sharing the same resource. And only when the last one goes out of scope, then the resource is destructed. No memory leak, no blowing up, no rule of 3, because you don't have a raw pointer in person anymore. You have a smart pointer in person. And as you can see, smart developers use smart pointers. I showed you in the demo how switching a raw pointer to a shared pointer from the standard library just makes all that work of the big 3 evaporate. And this is how it should be. There are 3 important smart pointers in C++11. Shared pointer, which as I've mentioned is a reference-counted, non-intrusive smart pointer, behaves well in collections, does everything you think it should do, really doesn't have flaws. Weak pointer, which sort of works with shared pointer. Every time you create a copy of a shared pointer, you bump the reference count. Sometimes you want to have a weak pointer which doesn't bump the reference count. Its existence doesn't keep the object alive, and it's possible that the weak pointer may become empty if the object goes away while the weak pointer is still pointing to it, and it handles that really nicely. There's also unique pointer, which can't be copied, and there's an algorithm available in the standard library called move that you can use to move values in and out of unique pointers. I should also probably mention auto pointer, a previous attempt at a smart pointer that was in the standard library. Auto pointer wasn't as smart as it should be, and it worked really poorly in containers. So if you made a vector or some other standard collection of employee objects, solid objects, that would work great. Or you could make one of raw employee pointers and it would work, but you'd have to delete all the individual employees when you deleted the collection. If you put smart pointer, auto pointer into that collection, extraordinarily bad things happened. Shared pointer and unique pointer don't have that problem. They work well in containers. Auto pointer does not. You should be using Visual Studio 2010 or Visual C++ 2010 Express. They have shared pointer and unique pointer. You therefore have no need in your life for auto pointer. In fact, if you find an auto pointer in old code that you're maintaining, you should give serious thought to replacing it because it's flawed in some important ways. Don't use auto pointer when you're writing new code. Use shared or unique pointer. They're the way to go from here forward. I showed you how much simpler using a shared pointer is, but perhaps you need to be convinced that it's actually usable as a pointer. Back in the copy constructor and the assignment operator, we had some calls to resources getName function, which you see here. And if you remember what those calls look like, it was just presource arrow getName. Let's come up with an excuse to call that from some other member function, a person, having now deleted most of the member functions of person that were managing resource, so that you can see how easy it is still to use the pointer. Let's come here into person and add a function called getResourceName. The resource name's a string. GetResourceName doesn't take any parameters, doesn't change the object, and it'll just return that presource points to, and you see I even get IntelliSense. presource is this shared pointer. It's not any kind of a pointer with a star, and yet because of the overload of the operator points to, I can call the methods just as though it was a traditional raw pointer. So I can call presource getName. And now I've implemented getResourceName. So back in here, if I want to, I can take any one of these persons and just declare another string. It could be on one line, but let's do it down here. String s1 is equal to, say, Kate dot getResourceName. And we've implemented that function, so that's going to work just fine, and we'll be able to bring the resource by calling getResourceName, which is going to use the smart pointer presource just as though it was a traditional raw pointer. One of the great things about this is that you can take code that was written using raw pointers, which is full of these arrow operators and so on, and just go and make this change so that you declare to be a shared pointer instead of a raw pointer. And then here use make shared instead of equals new, and that in very many cases, that and ripping out all the deletes is all that you have to do to switch over to a shared pointer. Once you've made the switch, you can forget that it's a shared pointer and just treat it as though it was a raw pointer everywhere in your application, dereferencing it with star where that's appropriate, and by using this points to operator. Simple as that. Some people are scared of pointers. There's really no need to be. Being scared of memory management, maybe, but not of pointers. Pointers and references are just another way to talk to the variables that you already have in your code. And if you want to use certain constructs within your code, passing by reference, passing by address, keeping a pointer to something in something else, you gotta learn to work the syntax. Where does the star go? When do you use the arrow? What does the ampersand mean? In order to work with pointers and references. But it's quite doable. Same with const. Const keeps your programs correct. It keeps you from accidentally changing things when you didn't mean to. You have some function called getName. It shouldn't change somebody's number, and the compiler will help you through that. It's especially important if you're writing any kind of a function that takes a parameter by reference but that might be given a literal like 3. And it tends to spread through your code. Once you decide that this operator takes a const reference, then you discover that, oh gee, that means getNumber has to be const and getName has to be const and this other thing has to be const. It's a much better habit to build const correctness in right from the very beginning. The minute you find yourself taking a reference, say, why am I doing that? Am I doing that because I want to change it? Or am I just doing it for speed so that I can avoid the copy? If it's just for speed, immediately say const whatever reference. Even if it doesn't matter to the compiler, it matters to other humans who read your code. Now they know why you're taking it by reference. It's just for speed. And there are a number of member functions that you can write in objects that have a standard canonical form. The copy constructor has to take a const reference to whatever this type is. The assignment operator, the same. The addition and arithmetic and comparison operators have a standard form that involves typically taking a const something reference and often returning references as well. So you need to understand references and you need to understand const in order to do a good job of writing operator overloads so that someone else doesn't come out and look at your operator overload and go, what? What? That's not what you return from that. Make it right. A real program, a program that doesn't just count to 10 or print someone's name out over and over again, are the kinds of demos we've been writing. Real programs involve long-lived objects. When the program starts running, somebody creates an object and many other parts of the application interact with that object throughout a long and healthy life. And that long and healthy life is almost certainly spent on the free store, which some developers call the heap. In order to allocate memory on the free store, you have to call new. That gives you a pointer, and then you have to live with pointers. You can't live a pointer-free life because you're going to need to get stuff living on the free store. That means you're going to have to be comfortable working with pointers. The thing is, it's not a done deal that means you have to do memory management by hand. If you knew something, you must either then take responsibility of following it around for the rest of its life to see if you should delete it, or, the smart thing, immediately put it in a shared pointer or a unique pointer, a smart pointer from the standard library. When you immediately put it in a smart pointer, you never have to delete it. The scope and the lifetime of that smart pointer, which is just a local object, an object on the stack, will control the lifetime of your free store memory and the destructor and all of the things associated with cleaning up. That's the smart thing to do. Smart developers use smart pointers. Manual memory management is hard. Smart pointers make your life simpler. I've shown you the hard way because I think you should know, not because I think you should run out and write the big 3 in all your classes for the rest of time. The smart thing to do is not to have to do that.